Hello guys, welcome to Indian Cybersecurity Solutions. So actually, first I the mic was stopped. Okay, so today I want to discuss about the topic is the implementing AI to combat cybersecurity threats, and also I'm going to discuss about how to neural network work. Okay, and how we can build our artificial neural network. Okay, so before going to start, actually I am Dipesh Kumar Barai here, and I am here is a machine learning developer. Okay. So today I'll discuss about the neurons and the activation functions, how our neuron work, okay, how actually our biological neurons work, and how the neural networks are activated, and how all the neurons are updated their bias and weights through the back propagation. Okay, all of the things I'm going to discuss about today, and also at the end I will discuss about the how to detect the phishing website through the by implementing AI. Okay, so before going to start about the deep learning, this is the man who we are called the godfather of deep learning. His name is Jeffrey Hinton, and he first give the idea actually how the neurons are. We can create our electronics neuron, and he is working at Google. Okay, so actually this is one a small picture of our biological neurons. Okay, and these are the dendrites and axon and how the neurons work. This is actually in our cell, the neurons are there. This is just as a look of our biological neuron. And the second thing, actually, how our neuron work. So this is basically the neuron. Okay, this is the dendrites. Okay, these take the input signals from the, like, our neurons take the input signals from our nose, eyes, and like taste and all of the things, and our neurons are activated and pass the signal through the action, and also it gives the signal to the other neurons by the axon actually, and these are all the neurons are connected. Okay, so in our cells there are billions of neural network, and all of the connected, and when someone touches your body, then you can able to know that someone touches your body, and how we can know. Okay, that's actually our biological neuron. You can think about one ant. A ant can't do anything, right? So if there are when they are building a colony. Okay, so for to building a colony, when the millions of ants are building a colony, so one ant can't do that. Okay, so actually there are 4 to 5 ants are there. Okay, those who are taking all the materials from here and there, and they are carrying it, and they come to the colony, and they build and they build their colony. And you can see at that time there are so many hundreds, and maybe there are millions of ants are there, and they building their colony. In that way, our in our cells, in our there are also the so many neurons are there. Okay, and all of the signals are going one neuron to another. Okay, step by step. Okay, then all the neurons are activated, and we can able to know our smells, okay, taste, okay, and everything. This is actually our biological neuron. Okay, this is very complicated process how actually it's work. Okay, so how neurons are connected. So you can see there are two neurons. This is the first neuron, and this is the second neuron, say, and they are connected to the others neuron, and they are passing their signals from one neuron to another neuron, right? The signals are coming, and the axon, this is actually the axon, and these are all the dendrites, and they are taking the signals from the another neurons. Okay, and they passing the neurons to the again another neurons. So if you zoom this side, you can able to see they are not totally interconnected to the other neurons. Okay, so they are passing the signals, but they are not totally connected to the other neurons. They are the passing the signals to the other neurons. Okay, so in that way, actually we if you look at our machine learning videos, then you can able to see we have already discussed about some linear and logistic regression algorithms, how actually this work. Okay, so this is the input feature. Suppose we want to predict the price of a house, right? So that's why we give some values like what, what is the age of the house, and what is the location, and how many floors are there. So all the input values we are giving, and then this is predicting the, yes, these features are there, the output will be this value. So all of the concept we are everything will means will discuss about in the machine learning. So everything will work here, and we'll create our electronics neuron. And this is also the logistic regression. We are giving the the input features, the same features over here, and this is predicting that actually the logistic regression work with the binary output, like 0 and 1, yes or no. Okay, so we are importing the values, and we are calculating the bias, we are average out it, and then it is predicting yes or no. Actually this function basically work for predicting a cell is malignant or benign. Also we can predict that the email comes to your email account, then that will automatically detect this is spam or not. Okay, so actually why I'm showing it, because all of the concept we'll use there to build a neuron. Okay, so basically the structure of the neuron is look like that. Okay, so this is basically the input signal, and if you compare it with our biological neurons, then you can see the input signals are maybe the nose, okay, maybe the eyes, okay, maybe our mouth. So all of the signals we are giving, and then we are the this is our the neurons, and neurons are activated, then we can able to see if so this rose is suppose this flower is rose. Okay, then we can able to know that. Okay, so how actually our neurons work and the electronics neuron, this is a very complicated process, but I am going to discuss about in a short way. Okay, so here suppose you want to predict actually the price of a house, right? So what would be the features? The features are like I have already discussed, that the age of a house, and how many floors are there, and also that the location also different. Okay, so all of the features and input signal, we are giving that input value in a small neurons, and this is predicting that yes, if these features are there, and the values are there, then the price can be the 1 lakhs, 2 lakhs, whatever it is, that depends upon the uh, that actually the depends upon the input values. Okay, and the neurons is automatically predicted that yes, the output value will be like this. Okay, this is our basically the small neurons. Okay, so let's see, so how actually our network work. Okay, so actually when we are giving the values like the age of a house, and also the location, also the suppose floor. Okay, so we are including here the weights. We are just multiplying it with this value, like w1x1 w1x1 plus w2x2 plus dot wm plus xm plus bias. Okay, so we'll get some values over here, and that is basically the z value. Okay, so after calculating this, how we can activate our neurons. Okay, so there are so many functions that I'll also discuss about that. Okay, so like then this is activated, and when it is predicting, and then after activated the neurons, then we'll get the output value. Okay, see, so this is the structure of this neuron. I am this is the weighted sum of the z. This is the z value. Then we are using here the sigmoid function. Okay, so suppose this is one the cancer. There is a one cancer is cell, and there are lots of things like the cell size, and so many medical features will be there. So I'm just calculating all the things over here. Then I am there. The activation function is sigmoid. Actually, sigmoid function what gives, that gives a, yeah, actually this function is very smooth, and that gives the value within the range from 0 to 1. Actually, this is the probability value. Suppose we give there the threshold is 0.5. So if the values this is predicting, that is which is greater than 0.5, so we can see that yes, this cell is malignant. Also, if it is the value is less than 0.5, then this value can be sorry, this cell can be the benign zero. So in this way we are just calculating the value. Okay, so there are some of the activation functions here, like threshold and sigmoid. So actually, how threshold function works? This is the threshold function. Actually, it is very simple. Okay, so it actually gives the 0 and 1 value. If it is less than 0, then that will give the value 0, and if it is greater than 0, then that will give the value 1. It's very simple, the activation function. Okay, so actually sigmoid function is very important. Actually, we are already discussed the sigmoid function, which is in logistic regression. Okay, it gives a value of 0 and 1. It is very smooth. Okay, so this is actually the threshold 0.5. Okay, so by actually we use this sigmoid function when at the end of the neurons, like in the output where the last hidden layer. Okay, so that is predicting the 0 and 1 value. Okay, so also there are some of the activation function like rectifier, which also which is known to ReLU. Okay, it and this function always takes the value which is greater than 0. Okay, this the all the values which is less than 0 and less than 0, and that will be in 0, and if the value is greater than 0, and only takes the those who are value is greater than 0. Okay, and one another activation function which is called the tangent function, and the range of this function is actually this is -1 and 1. Okay, so this actually really works some of the application, and this is the four main activation function. We'll use that in our to build our electronics neuron. Okay, and this is the picture of this all the activation functions. Like this is all the actually same that we have already discussed about. Okay. Okay, so actually how our activation functions work. Okay, so actually we give some input value. Okay, so and then suppose, okay, so first I want to discuss some of the coding part, that how actually we extract the value from a um, website, and then we will feed that data to our neurons to predict a website is phishing or not. Yeah. Okay, first I'm just importing some of the library like NumPy and Pandas. NumPy is basically to calculate the numerical values, and the Pandas is used for the data manipulation. We are first taking the sites like 0 and 1, where the 0 means this is not a phishing website, and 1 means the website is phishing. So, okay, this is the result, and we have previously got this data. Okay, so there are some of the links, and there are also some of the links. Okay, first, and these are the labels. Means if this is the URL, then the label is 1, and if 1 means this is a phishing website, and 0 means this is not a phishing website. Okay. So, okay, so basically, first our target is to extracting the data from this URL. Okay, so first we are taking two libraries here, that is URL parse and TLD. Okay, this actually works to collect the data from a actually website link. Okay, then first we are calculating data like what is the URL length, what is the host name length, and the path length. This is the URL, this is the host name. Okay, and this is the path length of. Okay, so then we are calculating all the things. Then if you look at the data from this URL, we are getting this is level is 0. We know already that previously we got this, and URL length is 20 type. Sorry, 22 means 22 characters are here. Okay, and host name layer is 14 and path name is 0. So all the data we are extracting from this link. Okay, and then step by step we are also counting that the how many this underscore sign is there, how many at the rate sign is there, and how many question marks are there, how many percentage are there. So after calculating all the things, then we are getting this data. Storage is running. This is very complex process is going on there. That's why it is taking some time. Okay, so at the end, after calculating all the things like how many in this link, how many at the rate is there, how many question marks is there, how many dots are there, how many equals are there. So we are getting this numerical values. Okay, so here the input values are the URL length, host name length. These are the all the input values. Okay, and the our output level is here, that is 0 and 1. Okay, so all the information we are extracting from this website. So at the end, we get the data set like this. It is working. Okay, so we got this data, and here this is the input values. Okay, so just I'll draw the neural networks here, how actually it's work. So this is the URL length, host name length, path length. Suppose you build a neuron like this, 1 2 3 and dot, dot, dot. Okay, so here input values are like URL length and the host name length and path length and all that. Okay, these are all the input values we will be giving here. Okay, then that is connected to some of the hidden layers. Like the in hidden layers, suppose there are 6 neurons. Then you say 1 2 3 4 5. So okay, all the neurons are connected to each other. Okay, and these are the layer 1. Okay, these are the neurons. Okay, so here we are calculating all the like all the input length with the weights vector, and we are just average out all the things, and then after that we are activate this. We have actually in the hidden layers we give our activation function relu, which is already I have already discussed about how actually relu was. Actually we are it's this all the inputs, this is connected through millions. We can do that. We can try, means whatever neurons we want to give, we can give there actually. So and at the rate we are just activated these neurons. Okay, this is suppose we are using the sigmoid function. Actually this give the two values. Okay, so some of the means the range of the values will be within the 0 and 1. So we give a threshold, suppose 0.5. So if the value is 0.5, then that is predicting that yes, this if these lanes are there in this link, so then that will predict that yes, this link is suppose phishing website, and if this input features are there in that links, then that will predict the uh, this side is not phishing. Okay, so actually we are extracting the value, and in x actually this is the input values like host name length, path length, fd length, tld length, count, and count of at the rate, count of underscore and question marks and all the other things. Okay, so the x values we are taking this type of values, and y value is label means this is 0 and 1. Okay, so we have already got the x and y value from this whole data set. Okay, then we are just splitting the data using the train test case. About test size is 0.3, means we are splitting the data using in 70% and 30%. Okay, so you can see now the extent length is 261194 and 17th columns are there, and the white end value is this is just one column, so that's why there is no value. Okay, so this is the things I'll discuss after sometimes. Okay, first let's complete all the things. Okay, so how actually we can build our neuron. So these input values to predicting a phishing website, these input values are like host name, length, how many signs are there, how many dots are there, and all the things. This is the input values, and we are calculating all the things with the weights, and then it is activated, and this is the predicting value. Okay, so actually this sigmoid function actually gives the value within 0 and 1. Okay, threshold function actually gives the same value, but sigmoid function gives the probability value within between the range of 0 and 1. Okay, so most of the times we are just take the value of sigmoid function. Okay, so this is, and this is activated all the neurons, and this gives the output. Okay, this is the all. This is the structure of this whole artificial neuron. How actually works? How they are all are connected with every neurons, and this called the hidden layer. And there are some of the neurons, and there is the input value, and this is predicting 0 and 1. So to build the artificial neurons, actually there are so many mathematics are going on there. So this is the weights that we will randomly generate, and the input value we are giving actually the host name length and all. So that is automatically calculated. This is the weighted, and this is the x features are there, and we calculated all the things. Okay, so we are just sum over all the things with bias. Okay, then if you calculate this, then that will be W transpose of X plus B. Means if you calculate this like X1 W1 plus X2 W2 plus dot 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 X D W D plus bias, and this is actually Z value. Okay, then we are taking here the sigmoid function to predict the value is phishing or not. Means that will predict the 0 and 1. Okay, this is gives actually probability value. Then sigmoid of Z, then it's give the value. If the suppose we are predicting that if it is the value is 0.5, that will predict this is a phishing website is less than 0.5. This is a mathematical function also actually the working over here. Okay, this is perceptron. This is just a one layer neural network. How we are calculating this. Okay, so we can actually get the good result by using by giving the many neurons. Okay, there are multi-layer neural networks. They are to predicting the value of 0 and 1. We are just using only one neurons, but here we are taking so many neurons over here, 1 2 3 too many. So then can be our accuracy can be very good by if you use lots of new neurons in our neural network. Okay, and actually the hidden layers extract the better representation of the input data. Okay, and then activate. This is the another neurons and how actually it's work step by step process. Okay, so here in hidden layer we use basically the ReLU activation function. This is all the taking the positive value, but in the output we use basically the sigmoid function. Okay, where the output is basically the binary, that is 0 and 1. Suppose we are by looking at the picture, just we have to predict that this picture is cat or dog. So for this problem we use uh, the output layer, we use the sigmoid function. Okay. Okay, so now the softmax function. So actually when we use the softmax function, softmax function is also give the probability value. Suppose you're just predicting so many things like there are just so many dresses picture, they're like shirt, pant, and so many things like uh, also sorry just you are predicting that so many fruits pictures, suppose apple and guava. Okay, so many apples pictures are there. So that time what will function? Actually, sigmoid function gives only the two probability values like 0 and 1. But when we use the softmax function, so that time it gives so many probability values. Okay, so then suppose the when it is predicting, okay, so this is predicting suppose for apples is 0.2. Okay, for guava that is 0.8. Okay, for the pineapple it is predicting suppose 0.6. So the maximum value will get, and all the probability will be the total value, all the probability. So that will be the 1, and the maximum value what that will predict, that will be the identifier of this, and that is when the our output value is more than 2. For that time, we actually use the softmax function. Okay. And this is actually the output value suppose for the apple, for the apple, for the guava, for the pineapple. Okay, and that time we'll use the softmax function at the end of the neuron, means output hidden when the output neurons is there. So in that time we'll use only the softmax function. Okay, the forward propagation. So we can see in multi-layer there are so many hidden layer there, and every time we are just calculating the weighted sum of the all the input values, and where we get one a value, and then we are thus activated the neurons by using ReLU, and again we are calculating the weighted value, and we are activating functions. So we can use so many hidden layers. Okay, so after that this is predicting the value. This is how actually forward propagation will work. Okay, so the signal is passed from one neurons to another, then one neurons to another, then one neurons to another. So okay, so in this way the forward propagation actually work. Okay, the back propagation. So sometimes when the neuron is predicted, and that can be different from the actual prediction value. Okay, so this is, suppose this is our true class and this is our prediction class. So if the difference is there, so we'll just calculate how many loss is there. Okay, then we calculate the loss. Then what we have to do? We have to update our weight and bias. This is where we are randomly giving that value. So in this, in back propagation, in step by step process, so all the weights and bias will be automatically updated. Okay, and then we are again go through the step by step process, and we'll predict that how many losses there we are able. Then we are again updated the weight and bias. In this step by step process, uh, we actually get the good accuracy, and this step by step process will show you in the coding tutorial and all the things. Okay, and this is the things where we are actually updating our bias and weights. Okay, now we can able to understand how actually we are giving the input value. It is the signal is going on there. So this is the output value and this is the actual value. We are calculating the loss, that is equal to half of. This is the prediction value and this is the actual value. So we get the sum value. We again go back and we are updating our bias, and we again come here and we are calculating our loss. And okay, so in this step by step process, we are by updating the weights and bias, we'll get the very good accuracy. So okay, if you can see the first hour, suppose the loss is very high here, then after 2 or 3% the loss is decreasing. Okay, so the that can be after that 5 epochs. We say the 5 steps, right? We'll use the epochs. So after 5 epochs, you can see there is no loss. Means we get the good accuracy. Okay, there is no loss means whatever the actual value, our prediction value is the same. Okay, so in this way, we'll just build our neural network. Okay, so let's see how we can detect our phishing website detection through this neural network. Okay, so first I'm just importing some of the libraries like TensorFlow, Keras. Okay, and this is the main two libraries. Okay, I just imported it. Okay, then you can see we are just value equal to just the output value is 0 and 1. So we are just doing the auto encoders. Means suppose where the one is there, so we are taking that is 1 0, where this is not 0, that is 0 and 1. We are just we're doing the auto encoders over here by using val. Okay, so there is the specific library care so equals to category. Okay, then first we are just initializing artificial neural network, that is the sequential model is equal to sequential. Okay, so there are 17 input layers. You can see there are 17 features, and dense is 16. Means in hidden layer there are 6 neurons. Okay, so again there is a another hidden layer. There were also the 6 neurons are there. Okay, and all the neurons are activated through the ReLU function. Okay, so then and the output function is here is 2. Okay, that will predict the value of 0 and 1. If it is fishing, the probability will be less. If it is not fishing, the probability value will be high. Okay, so we are just building a very simple neural network, and the epoch is 10. Means I am using an only 10 epochs. Means 10 step it will update it, their bias. Now after that, we are optimizer is Adam. Actually, Adam gives a good result here, and loss is binary cross entropy, because to predicting the value of 0 and 1, we'll use binary, and if it is greater than 0, if the prediction value is greater than 0, then we'll maybe use the categorical cross entropy. And okay, we can use the sparse categorical cross entropy. Okay, so now I'm just running this neural network. So you can see it is running the, okay, and the accuracy score is here 83 point, and it is increasing. So and the loss is 47 point something. Okay, and the value is increasing. Let's see what's happened. To calculate by calculate the 10 steps, that will take some times. Okay, so first steps it is giving the value is around 89%. Okay, so I think in the next step the value will be better. The accuracy score will be better than that. Okay, so you can see there is 92%. So at the end, value will be around 92 to 93%. I think. Is slightly increased than previous. That is first time that was 92.30 and now the accuracy score is 92.90. It is increasing. Okay, so after that we are getting after 4 epochs. The accuracy score is 93.05, slightly increasing. We'll check up to 10 epochs. Again, it is slightly increased from 93 point, no, sorry, 0.93052 to 0.9635. Again, it's increased 35 to 44. Now 0.9344 to 0.9350, slightly increased. Okay, so I think the accuracy will be is around 93 to 94%. It is actually good. Means within 100 of data, that is means 93 side, it will predict this actually true results. This is last epoch, and at the end we are getting the last accuracy score is 93.52. Let's see what will be the accuracy score after 10 epochs. Okay, so we got the accuracy score 93.49, which is actually very good. Okay, so let's see. So using the x test value, we just also comparing the x train and our y train values, and we'll get the values around 94 maybe. Is calculating the value. So we are getting 93.31 accuracy score. Okay, so first we are just defining function where all the values will be calculated here. Okay, then just run this. Now it is the time to check the outputs. Okay, so first I'll take that is a good link. Suppose we are searching the Google. Okay, just copy this link and paste it over here. So when I'm giving the link of Google, it is expecting that you are using the same website. Okay. So let's see the probability score. So for the same website, we are getting 99% accurate. Okay. This website is uh, the same website. The accuracy is 99%. This model is telling me that is 90. We are giving that is a 99% accurate. Okay. So let's take any phishing website. Okay, so there are so many phishing websites. I'm just taking only one, any one of this. It is saying that you are, sorry, maybe. Just giving some problems. So wait a minute. So this is not a good example of the website, maybe. Okay, so we have to check by the good phishing website link. Then that will maybe predict the this is phishing is this website is phishing or not. So if we have some actual data, so then we can able to see. So this is actually we are just we build our neural networks and to predict a link is phishing or not. Okay. So guys, this is all about the live lessons. If you have any questions, you can ask. So you can see, so there is some of the links. Actually, I actually got some, you know, the another website. So when I'm giving any phishing website here, so that is predicting that this is beware from this phishing website. Okay, so it is slightly working. Okay, so in that way we can predict any website is phishing or not. Guys, if you have any question, you can ask. Thank you guys for joining this live lesson.